What if one man, a single human being, was responsible for more deaths than Hitler, Stalin, and Mao combined? Not a warlord, not a dictator, not a terrorist. A chemist. A friendly, well-meaning American chemist who just wanted to make the world a better place. His name was Thomas Midgley Jr. And history has quietly buried what he did because what he did was never supposed to happen. He didn't build a weapon, he didn't start a war. He invented two things that the entire world celebrated, two things that won him medals and standing ovations. And those two things, slowly, invisibly, across decades, poisoned the blood of every living human on Earth and cracked the shield protecting all life from the sun. This is not a story about evil. This is something far more terrifying, a story about good intentions gone catastrophically wrong. Thomas Midgley Jr. was born in 1889 in Beaver Falls, Pennsylvania. He grew up in a family of inventors. His father held multiple patents, and that spirit of problem-solving ran deep in his blood. By the time he reached college, Midgley was obsessed with one question: how does chemistry fix the real world's problems? He wasn't the dark, brooding scientist type. He was charming, social, genuinely funny, the kind of guy people wanted to work with. After graduating from Cornell University in 1911, he joined the Dayton Engineering Laboratories Company, better known as Delco. That's where he met Charles Kettering, his mentor, the man who would point him toward the problem that changed everything. The problem was called engine knock, a violent, destructive shuddering inside car engines that wasted fuel and destroyed motors. In the 1910s, the automobile industry was exploding. Cars were everywhere, and this knocking problem was holding the entire industry back. Kettering handed Midgley the assignment: find a fix, find it fast. Midgley threw himself into the lab. He had no idea what he was about to discover would outlive him by 100 years, and not in a good way. After years of experimenting, Midgley landed on a compound called tetraethyl lead, or TEL. When added to gasoline in tiny amounts, it eliminated engine knock almost completely. It was cheap, it was effective, and it was scalable. In 1921, he filed the patent. General Motors and Standard Oil rushed to commercialize it. Leaded gasoline was born. The world was thrilled. Cars ran smoother, engines lasted longer. The automobile revolution kicked into a higher gear, literally. But here's what Midgley knew, and what his employers knew, and what the public was never told. Lead is a neurotoxin. It had been known to be deadly for over 2,000 years. Ancient Romans wrote about it. Medieval doctors warned against it. Workers at the leaded gasoline production plants were suffering: hallucinations, seizures, violent outbursts, death. At one facility in New Jersey in 1924, 5 workers died within days of each other. 35 more were permanently disabled. Midgley himself had been poisoned by his own invention. He took a long medical leave to recover from lead exposure, the very lead he had unleashed on the world. And when he came back, he stood in front of journalists, poured leaded gasoline over his hands, held it to his nose, and smiled, telling reporters it was perfectly safe. He knew it wasn't. For the next several decades, leaded gasoline flowed through the veins of civilization. Billions of cars, billions of gallons, lead particles released into the air with every exhaust puff, breathed in by children, adults, and elderly people across the entire planet. Lead doesn't leave the body easily. It accumulates in bones, it settles in the brain.
In children, it permanently reduces cognitive development. Researchers later estimated that at the peak of leaded gasoline use, nearly every child in the industrialized world had blood lead levels high enough to cause measurable IQ reduction. Some scientists have connected the lead exposure era to widespread rises in violent crime rates across the 1960s, 70s, and 80s, a hypothesis now taken seriously in criminology. The industry fought every attempt to study it, ban it, or restrict it, funded counter-research, lobbied governments, discredited whistleblowers. The U.S. didn't begin phasing out leaded gasoline until 1973, over 50 years after Midgley's patent. It wasn't fully banned in the United States until 1996. Globally, some countries were still using it into the 2000s. Algeria became the last country to officially ban leaded gasoline in 2021. 100 years of a known poison pumped into the global atmosphere. And Midgley wasn't done yet.
By the late 1920s, Midgley had already secured his place in industrial history. But his bosses at General Motors had a new problem for him: refrigerators. Early refrigerants used coolants like ammonia, methyl chloride, and sulfur dioxide, all of which were toxic, flammable, and occasionally lethal if they leaked inside your home. Accidents were happening. People were dying. The public was terrified of the machines meant to keep their food fresh. The industry needed a coolant that was safe, stable, non-flammable, and non-toxic. They needed a miracle molecule. Midgley, working with colleagues, synthesized it in just 3 days. They called it Freon, the first of the compounds known as chlorofluorocarbons, CFCs. To prove its safety, Midgley performed his now famous demonstration. He inhaled Freon deeply, then exhaled it over a candle flame, which didn't ignite. The crowd applauded. Freon was declared a miracle. It rolled out globally. Refrigerators, air conditioners, aerosol spray cans, industrial cooling systems, everywhere. For decades, it seemed like the perfect invention. Non-toxic to humans, non-flammable, chemically inert. What could possibly go wrong? Everything. Everything could go wrong. It just took 40 years for anyone to notice. Thomas Midgley Jr. was a man who seemed to court disaster the way other men court luck. In 1940, at the age of 51, he was struck by polio. The disease left him severely disabled, confined mostly to his bed. But even then, even broken and immobilized, Midgley's mind kept working. He designed an elaborate system of motorized ropes and pulleys that would help him lift himself out of bed without assistance. He was proud of it. It was elegant, clever, and exactly the kind of engineering solution a man like him would love. In November 1944, the ropes tangled around his neck while he was using the system. Thomas Midgley Jr. was strangled by his own invention, dying at 55 years old before the world ever realized what his other inventions had done. Historian J.R. McNeill would later write that Midgley had more impact on the atmosphere than any other single organism in Earth's history. That sentence deserves a moment of silence. One organism, more atmospheric impact than any volcano, any ice age event, any other single species on the planet. A man with a chemistry degree from Cornell. It was 1974. 30 years after Midgley's death. 2 scientists named Sherwood Rowland and Mario Molina published a paper that sent shockwaves through the scientific community. Their finding? CFCs, Freon and its chemical cousins, were rising into the stratosphere and destroying ozone molecules. The ozone layer is Earth's sunscreen, a thin chemical shield sitting 15 to 35 kilometers above the surface, blocking the sun's ultraviolet radiation. Without it, UV radiation hits the surface unfiltered. Skin cancer rates explode, ecosystems collapse,
Phytoplankton, the foundation of the ocean food chain, dies. Rowland and Molina's paper was met with fury from the chemical industry. Sound familiar? The same playbook used against lead researchers was deployed again: deny, discredit, delay. Then, in 1985, British scientists discovered the Antarctic ozone hole, a massive seasonal gap in the ozone layer directly above the South Pole. It was so large, so undeniable, that the entire conversation changed overnight. The public was terrified. Governments were forced to act. Rowland and Molina would later win the Nobel Prize in Chemistry in 1995 for their discovery. And the world finally began dismantling the second legacy of Thomas Midgley Jr. In 1987, the Montreal Protocol was signed, one of the most successful international environmental agreements in history. Nearly every nation on Earth agreed to phase out CFCs and related compounds. It worked, slowly, painfully slowly, but it worked. By the 2010s, scientists began measuring early signs of ozone layer recovery. As of 2024, projections suggest the ozone layer could return to 1980 levels by approximately 2066. That's 40 more years of healing from damage caused by a compound that was in widespread use for less than 60 years. Meanwhile, leaded gasoline's legacy continues in the bodies of billions of living humans today. Lead that was absorbed into bones during childhood stays there for decades. Scientists estimate that people born before 1980 carry measurably elevated lead levels compared to pre-industrial baselines. A landmark 2022 study in the Proceedings of the National Academy of Sciences estimated that leaded gasoline exposure reduced the collective IQ of the American population by an average of 2 to 5 points. Across an entire population, for generations. The cost in human potential, in health outcomes, in lives lost to lead-related illness is genuinely incalculable.
Here is what we know now, with full scientific clarity in 2026. Atmospheric lead levels during the peak of leaded gasoline use were approximately 300 times higher than natural pre-industrial levels. No corner of Earth was untouched. Lead particles were found in Arctic ice cores, in remote Pacific Ocean sediment, in the tissues of wildlife thousands of miles from any road. The ozone hole, at its maximum recorded size in 2006, covered an area larger than the continent of Antarctica. Increased UV exposure during the decades of ozone depletion contributed to a documented global rise in melanoma and other skin cancers. Researchers studying the lead crime hypothesis have found statistically robust correlations between childhood lead exposure and rates of violent crime 20 years later across dozens of countries. Every piece of data, every study, every ice core sample and satellite image points back to the same source: two chemical compounds, both invented by one man. Thomas Midgley Jr. never intended any of this. That's not an excuse. It's a fact that makes this story more unsettling, not less. Because it means the system around him, the corporations, the regulators, the incentive structures of industrial capitalism, allowed and amplified the damage long after warning signs appeared. Midgley was one man, but the machine that deployed his inventions and suppressed the evidence was built by thousands. Thomas Midgley Jr. does not appear in most history textbooks. There are no monuments to him, no national days of remembrance, no cautionary museum exhibits bearing his name, at least not yet. And that might be the most dangerous part of this story. Because the lesson here isn't just about one man's chemistry, it's about how we evaluate progress. Every invention that Midgley created was celebrated as a solution.
It solved the problem right in front of everyone's face. Nobody asked what it would do 50 years later. We are living in an era of faster invention than at any point in human history. AI systems, gene editing, synthetic biology, novel chemical compounds, nanotechnology. Each one celebrated as a miracle, each one carrying within it unknowns that we may not fully understand for decades. The ghost of Thomas Midgley asks us one question, a question worth sitting with. Are we making sure to look far enough down the road? Or are we still pouring leaded gasoline over our hands and smiling for the cameras? If this story changed the way you think about progress, about who gets remembered and who gets forgotten, then maybe the most important thing you can do right now is share it with someone who needs to hear it, because the world runs better when more people ask harder questions.